Welcome to ACT Pradhanana scheme for preparing SASG students for higher education, especially for GATE students. Erode Sengundar Engineering College organizes this program. I introduce myself. I'm Mrs. K.S. Rekha from Mathematics Department, Erode Sengundar Engineering College. Today I am going to handle the session Complex Variables. So here GATE syllabus for triple students. First one linear algebra, second one calculus, third one differential equations, fourth one complex variables, fifth one probability and statistics. So in this complex variable, various subtopics are there. Analytic functions, Cauchy's integral theorem, Cauchy's integral formula, Taylor's series, and Lorentz series, residue theorem, then solution to integrals. So here are the few applications about complex variables. Solutions to two-dimensional Laplace equation by means of conformal mapping, quantum mechanics, series expansions with analytic continuation, transformation between special functions, contour integrals, this evaluate definite integrals and series, invert power series, form infinite products, asymptotic solutions, stability of oscillations, invert integral transforms, and then last one, generalization of real quantities to describe dissipation. For example, refraction index, n tends to n plus ik, and then energy tends to E plus I into del. So first we see about complex variables and functions. So complex variables is we have to denote it as x plus iy. Here x is the real part and y is equal to y is the imaginary part. And then I represents square root of -1. Next complex conjugate. Complex conjugate is nothing but x minus iy. And then polar representation. Polar representation is z is equal to r into e power I theta. Here r is the modulus, that is square root of x square plus y square, and then theta is the argument, that is tan inverse of y divided by x. And then e power I theta formula represents cos theta plus I sin theta. So here multi-valued functions are nothing but single valued in each branch. Here are the one example of polar representation is z to the power 1 by m is equal to r to the power 1 by m into e power I into theta plus 2 pi n divided by m. So here m represent the branches, and we are getting the answer, that is log of z is equal to log r plus I into theta plus 2 pi n. There has an infinite number of branches. So next we have to see about the Cauchy-Riemann conditions. So Cauchy-Riemann condition is nothing but its derivative exists. First the function means its derivative exists. This that is a user, if u is a real part means, and then v is a imaginary part means, we have to differentiate both with respect to x and y. So both the conditions are satisfied means we called it as Cauchy-Riemann conditions. So Cauchy-Riemann condition is dou u divided by dou x equal to dou v divided by dou y, and dou u divided by dou y is equal to minus into dou v divided by dou x. So here are the few examples for analytic functions. So analytic is nothing but we have to check the Cauchy-Riemann condition, whether it is satisfied or not. If it is satisfied means it is called as analytic function, its derivative exists. If not means it is not an analytic function. So here our function is z square. So we write z square as x square minus y square plus 2I into x into y equal to u plus iv. So here u equal to real function, that is x square minus y square, and then v is equal to 2xy. So we have to differentiate u with respect to x. We are getting 2x, and then v with respect to y, again getting 2x. And then second condition, that is u with respect to y, you are getting minus 2y, and then v with respect to x. V with respect to x, we are getting 2x, but formula is minus into, so we are finally we get minus 2 into y. So both the conditions are satisfied. So both the conditions are satisfied means its derivative exists, and also it's a single valued function. So z square is an entire function. Entire function means it is analytic. Second example, complex conjugate is not analytic. You have to check that. So f of z equal to z star, that is equal to x minus iy. So that is equal to u plus I into v. So here u is a real function, that is x. V is the imaginary part, that is minus y. You have to check the Cauchy-Riemann condition. So first condition is u with respect to x. U with respect to x means we get 1, but v with respect to y means we get minus 1. Both are not equal, so first condition is not satisfied. Second one, u with respect to y equal to 0, and then v with respect to x is equal to again get 0. So this second condition is satisfied. So f dash doesn't exist. F in doesn't exist means its derivative is not exist. So it is continuous everywhere. So continuous everywhere but not exist. So therefore z square is nowhere analytic. Nowhere analytic means it is not analytic. Next we see about Taylor's series. So definition and formula. So if f is defined in the interval containing a and its derivatives of all orders exist at a, its derivative of all orders exist at a, we can call it as Taylor series. Then we can expand f of x as f of a plus f dash of a divided by 1 factorial into x minus a plus f double dash of a divided by 2 factorial into x minus a the whole square plus f triple dash of a divided by 3 factorial into x minus a the whole cube plus etc. Then Laurent series formula. So f of z is equal to summation n is equal to 0 to infinity an into z minus a to the power n plus summation n is equal to 0 to infinity bn divided by z minus a to the power n. So here where an equal to 1 divided by 2 pi I into integral over c1 f of z divided by z minus a to the power n plus 1 into dz, and then bn equal to 1 divided by 2 pi I into integral over c2 f of z divided by z minus a to the power minus n plus 1. Next one, singularities. So many singularities are there. So here are the few examples for singularities. First we see about singular point. Singular point means it is not analytic at is it not, is it not, it is not analytic at is it not. And then isolated singularity. Isolated singularity means if f is analytic on the deleted disk, it is a 0 less than modulus of z minus z not less than or. So here are the few examples for isolated singularity. So f of z equal to z plus 1 divided by z cube into z square plus 1 as isolated singularities when z is equal to 0 comma plus or minus I. And then second example, e power 1 by z. So it has also an isolated singularity at z equal to 0. And then third one, f of z equal to log z, and it also has an isolated singularity at z equal to 0. But it is not isolated because a branch cut, and then starting at z equal to 0 is needed to have a region where f is analytic. And then next one, sine of, that is 1 divided by sine of pi by z. It also has singularity set z equal to 0 and z equal to 1 by n. So next slide is previous year gate questions. So, so first question, for an analytic function f of x plus iy equal to u of x comma y plus iv of x comma y, where u is given by u equal to 3x square minus 3y square. The expression for v, considering k to be constant. Considering k to be constant, here are some options are there. So we first, what is mean by analytic? Analytic is Cauchy-Riemann condition is satisfied. That is, its derivative exists or not. So here u is given. U is that is the real part is given. That is 3x square minus 3y square. So we have to check the condition. So first condition is ux. That is u with respect to x. Differentiate u with respect to x. That is 6x. And then u with respect to y. So u with respect to y means again we are getting 6x because of using first equation. Because of using first one. So again v equal to, so here v is not given, but here the expression for v considering k to be constant. So we have to take v as 6xy plus phi of x. 6xy plus phi of x. So first differentiate with respect to x means we get 6y plus phi dash of x. Again, second condition for uy, that is uy is equal to 6y plus phi dash of x, that is using Cauchy-Riemann conditions. So again 6y is equal to 6y plus phi dash of x, that is using second condition, this one. So 6y cancelled, we get pi dash of x is equal to 0. So pi dash of x equal to 0, again integrate this one, we get pi of x is equal to k, that is constant. So here the expression for v considering k to be constant, isn't it? So we have to substitute this one as k. So therefore v is equal to 6xy plus k. That is a substitute, instead of phi of x we get k. So the final answer is 3x square 3y square minus 3, this one, what the answer, 3y square minus 3x square plus k, or 6x minus 6y plus k, or 6y minus 6x plus k, or 6xy plus k. So finally we got 6xy plus k. 6xy plus k is the answer for this question. So second question. So again, an analytic function of a complex variable z equal to x plus iy is expressed as f of z equal to u of x comma y plus iv of x comma y, where I is equal to square root of minus 1. If u equal to x into y, the expression for v should be. So here we should be what is x plus y the whole square divided by 2 plus k, and then second option x square minus y square divided by 2 plus k, and then third option y square minus x square divided by 2 plus k, and then fourth option x minus y the whole square divided by 2 plus k. So again we go for a Cauchy-Riemann condition. So here Cauchy-Riemann condition is ux plus vy, and then uy equal to minus vx. So here we take a u equal to, imagine that is a real part, u equal to xy. We have to differentiate u with respect to x. We got a y, and then v with respect to is also y because of Cauchy-Riemann condition. So again, integrating this one, we get y square divided by 2 plus some constant function. So again Vx is equal to, that is V with respect to x is equal to, so this one gets 0 and this one gets c dash of x. So again using Cauchy-Riemann condition, Vx is equal to minus uy. So the again rewrite as minus uy equal to c dash of x. So here uy is equal to, again u with respect to y is equal to getting x. So we substitute in those equation. This minus x is equal to c dash of x. So integrating, so again and again we get c of x is equal to minus x square divided by 2 plus k. So again from third condition we get v is equal to, that is this one, v is equal to y square divided by 2 plus c of x. So here c of x is minus x square divided by 2 plus k. So we simplified and rewrite as v is equal to y square minus x square divided by 2 plus k. So here given options is C1 is correct. Given option C1 is correct. And third one problem. Third one, for example, for singularities, we have to check the singularity. Third question, the analytic function f of z equal to z minus 1 divided by z square plus 1 has singularities at options are first one 1 and minus 1, second one 1 and I, third one 1 and minus I, fourth one I and minus I. So first we have to take the function f of z is equal to z minus 1 divided by z square plus 1. So we the denominator we can rewrite it as z square plus 1 is equal to z plus I into z plus I. So again denominator equal to 0, that is z plus I into z minus I is equal to 0. Get the singularities at z equal to I comma minus I. So option D option is correct. Then fourth question, let z cube equal to z bar, where z is a complex number not equal to 0. Then z is a solution of. So given options are z square equal to 1, z cube equal to 1, z power 4 equal to 1, and then z power 9 is equal to 1. So given function is z cube equal to z bar. We have to multiply z on both sides. That is z power 4 equal to modulus of z square. So now by hit and trial method, we see the solution. That is z power 4 equal to 1. Z power 4 is equal to 1 is the option. The C option is correct. So next question. And the polynomial p of x is equal to x power 5 plus x plus 2 has options are a first one all three real and two complex. They are given from first one have positive and second term also have positive and third term also have positive. So p of x has no positive real roots. So again negative sign. So here p of minus x is equal to minus my plus, taking only sign from each term. So here also p of x has one negative real root. As p of x of degree 5, so other four roots are complex. So of other four roots are complex. So sixth question, next one. It is known that two roots of the nonlinear equation x cube minus 6x square plus 11x minus 6 is equal to 0 are 1 and 3. The third root will be first option j, second option minus j, third option 2, and then fourth option 4. So we have to take the polynomial equation, that is here a polynomial equation, that is x cube minus 6x square plus 11x minus 6 is equal to 0. You have to take it. The third root will be here, the root will not be given, so third root will be alpha, so we have to take this one. So let third root be alpha of x power 5 minus 6x square plus 11x minus 6 is equal to 0. So we have to write this one as 1 plus 3 plus alpha equal to 6. Again, simplified those equation, we get alpha equal to 2. So alpha equal to 2 is the answer. So again, seventh question. If z equal to x plus jy, where x and y are real, comma, the value of modulus of e power j z is. So if z is given, the value of e power j z is what we get is. So first option is given as 1. Then second one e into square root of x square plus y square. Then third option e power y. Then fourth option is e power minus y. So first to take the value, that is a modulus of e power j z. So here z is complex variable, we know that. So just substitute in z. So again separate those values, that is e power minus y plus j into x. We have to separate this one. So we are finally we get e power minus y into e power jx. So here e power jx is real value, so value is 1. So we have to substitute in those equation. Finally we get e power minus y. So e power y is the answer. So in eighth question, one of the roots of the equation x cube equal to j, where j is the positive square root of minus 1, is first one j, second one root square root of 3 by 2 plus j into 1 by 2, and then third option square root of 3 by 2 minus j into 1 by 2, and then d option minus square root of 3 by 2 minus j into 1 by 2. So here are the solution. So here x power x power 5 is equal to j. So here sorry, x cube equal to j. We have to take a x cube equal to in terms of e power j pi by 2. So j pi by 2. Again we cube both sides we are substitute in cube, that is x is equal to e power j pi divided by 6. That is the e power in terms of this one as e power I theta. So here e power I theta means cos theta plus I sin theta. So in that format we have, so we can rewrite it as cos pi by 6 plus j into sin pi by 6. So we know that cos pi by 6 is root 3 by 2 plus sin pi by 6 is j into 1 by 2. So finally B option is the correct one. B option is the correct one. So ninth question, the root mean squared value of x of t equal to 3 plus 2 into sin t into cos 2t is. So here option root 3, B option square root of 8, C option square root 10, D option square root 11. So here given x of t is, that is a real mean squared value is 3 plus 2 sin t into cos t. So formula again substitute formula for sin a cos b. So here sin a cos b is sin of a plus b minus sin of a minus b. So substitute in those real valued function. Finally we get 3 plus sin in 3 plus sine 3t minus sine t. So again we have to take a root mean square, that is square root of constant square plus this one sine 3t, that is the real value is 1, and then this one also having 1, so that is 1 square. So finally answer is square root of 11. So D option is the correct one. 10th one. 10th one, the modulus of the complex number 3 plus 4i divided by 1 minus 2i is. Option are first one A option is 5, second B option is root 5, C option is 1 divided by root 5, and then D option is 1 by 5. So here given complex number is 3 plus 4i divided by 1 minus 2i. We have to take the conjugate for the denominator, that is 1 minus 2i conjugate is 1 plus 2i. So for solving this equation we have to take the conjugate. So uh, multiply both numerator and denominator by conjugate, and for a numerator we have to multiply those terms, that is 3 plus 4i and 1 plus 2i, we are getting minus 5 plus 10i. And then for denominator we have to multiply 1 minus 2i into 1 plus 2i. So we have to multiply and simplify those terms, we are getting 5. So again finally we have to take 5 is common. So 5 is common means final answer is minus 1 plus 2i. So question for the complex number is modulus of the complex number. So we have to take modulus value for minus 1 plus 2i. So minus 1 plus 2i modulus value is just to take minus 1 the whole square, square root of minus 1 the whole square plus 2 the whole square, that is square root of 5. Okay. Then next question. So next question and the form, that is a polynomial equation. So roots of the algebraic equation or what we get. The answer for the algebraic equation options are 1 j minus j, 1 minus 1 1, 0 0 0, minus 1 j minus j. So here we take algebraic equation, that is x cube plus x square plus x plus 1 is equal to 0. So we have to find the roots for the algebraic equation. Correct. So we have to choose the number minus 1. So minus 1 we have to choose. Substitute, so the factor are if we are substituting in the algebraic equation, that is now minus 1 is substituting in the equation, we are getting the term as 0. So x plus 1 is a factor of this equation. So again second, roots, we have to find the roots, isn't it? So write the algebraic equation, that is x cube plus x square plus 1 is equal to 0 as x square into x plus 1, again plus 0 into x plus 1 plus 1 into x plus 1. So uh, so for this we have to finally we have to find the factor for the algebraic equation is x plus 1 into x square plus 1, that is equal to 0. So here x is equal to 1 comma minus j comma plus j are the roots of the algebraic equation. So option 1 comma minus j comma plus j. So option A is the correct answer. Option A is the correct answer. So from the residue topic, we see some examples. So first question: the residue of the complex function, that is f of z equal to 1 divided by x plus 2 the whole square into z minus 2 the whole square at z equal to 2s. So this one is a gate question, so from 2008. So option are: first one minus 1 by 32, B option minus 1 by 16, C option 1 by 16, 1 6, and then D option 1 divided by 32. So first we have to find the poles for the equation, and also that is from the equation we have to find the poles. This is a plus 2 the whole square, that is a pole of order, pole, and also for order we have to find. So here pole is for z plus 2 the whole square, pole is minus 2, and then z minus 2 the whole square, here pole is 2, but here of the same order, that is 2 comma 2. So we have to find the residue for those function. That is residue at z equal to 2 is this limit z tends to 2, d by dz of z minus 2 the whole square into f of z. So here, f of z as a function is what? 1 divided by z plus 2 the whole square into z minus 2 the whole square. So again z minus 2 gets cancelled. So finally we have 1 divided by z plus 2 the whole square. So we have to differentiate this term. It is 1 divided by z plus 2 the whole square. We have to differentiate this one. So differentiate this one. Finally we get minus 2 divided by z plus 2 to the power 5. Okay. Again, limit z tends to, we have to substitute z is equal to 2. So we have substitute means we are getting, finally we get minus 1 divided by 32. Minus 1 divided by 32. So option A is correct. So again, second question for residue problem. The residues of a complex function x of z is equal to 1 minus 2z divided by z into z minus 1 into z minus 2 at its poles are. So option are 1 by 2 comma minus 1 by 2 and 1, and B option 1 by 2 comma 1 by 2 and minus 1, and then C option 1 by 2 comma 1 and minus 3 by 2, and then fourth option 1 by 2 comma minus 1 and 3 by 2. So this is also a gate question for 2010 question. So we have to find the poles. That is first we have to find the poles. That is for this function, that is 1 minus 2 z divided by z into z minus 1 into z minus 2. Here the poles are, so substitute denominator equal to 0. That is first pole are 0, and then z minus 1 is equal to 0, we are getting 1, and then z minus 2 equal to 0, we got 2. So simple poles are 0 comma 1 comma 2. Here of the order is 1, so it is called a simple pole. So again come to residue point. So residue of x comma 0, that is at pole z equal to 0, we have to find the residue value. It is limit of z tends to 0, z minus 0 into x of z. So here x of z is 1 minus 2z divided by z into z minus 1 into z minus 2. So z cancelled, we get finally 1 minus 2z divided by z minus 1 into z minus 2. So again substitute z is equal to 0. Z is equal to 0. So we finally got 1 by 2 is the answer for simple pole, that is z equal to 0. Then second simple pole 1. So second simple pole 1 is a limit z tends to 1, z minus 1 into x of z. So here x of z is 1 minus 2z divided by z into z minus 2. So substitute, so again z minus 1 1 cancelled, we get finally 1 minus 2z divided by z into z minus 2. So again substitute z is equal to 1. Substitute z is equal to 1. So finally we got 1 as the answer for simple pole 1. Again, residue of x comma 2. Residue of x comma 2 is limit z tends to 2 x z minus 2 into x of z. So here x of z equal to 1 minus 2 z divided by z into z minus 1 into z minus 2. So again z minus 2 z minus 2 cancelled, we get 1 minus 2 z divided by z into z minus 1. So z equal to 2, substitute means finally we got minus 3 by 2 for for the answer for simple pole 2. So option 1 by 2, 1 minus 3 by 2. So C option is the correct answer. C option is the correct answer. So next question. So next question is for not residue, but for complex variables problem. Okay. For the function of a complex variable w equal to log z, where is w equal to u plus jv and z equal to x plus jy. The u equal to constant lines get mapped in z plane as. So answer are set of radial straight lines, set of concentric circles, set of confocal hyperbolas, set of confocal ellipses. So what we given is w equal to log z to the base e. So here w equal to given are u plus jv. That is the analytic function, and then z is complex function, that is x plus iy or jy, anything. So you have to here they take I. So here w plus iv equal to log of x plus iy. So here log of x plus iy is nothing but 1 by 2 into log of x square plus y square plus I into tan inverse of 1 by y by x. So here u is constant, that is a real part. So we have to take this one as a constant. It is 1 by 2 into log of x square plus y square equal to c. So here we can taking log on both sides exponential. Finally we got x square plus y square equal to c. That is x square plus y square c is represented as concentric circles. Represented as concentric circles. So option B is the correct answer. Option B is the correct answer. Then fourth problem for residue. That is the value of the contour integral. So here contour or integral also very important. But for the residue, if but for residue is very important. Contour integral is little more important enough. The value of the contour integral, that is closed integral modulus of z minus j equal to 2, 1 divided by z square plus 4 into dz in positive sense is A option j pi divided by 2, B option minus pi by 2, C option minus j pi divided by 2, D option pi by 2. So here function, that is 1 divided by z square 4 is the function. We have to write the denominator as z plus 2i into z minus 2i. So for the is closed interval, that is modulus of z minus j equal to 2, isn't it? So we have to rewrite it as, that is modulus of z minus I equal to 2. So here from the denominator we have to take the pole, that is z equal to 2i. Z equal to 2i is the pole of order 1. So here pole is of order 1. So again we have to take the residue for 2i. So therefore residue of f comma 2i equal to limit z tends to 2i, z minus 2i into f of z, this one. So again z minus 2i get cancelled. Finally we get 1 divided by z plus 2i. So z plus 2i, substitute z is equal to 2i. So finally we got 1 divided by 4i. So closed interval for f of z into dz equal to, final answer is 2 pi I into 1 divided by 4i. That is 4 cancelled, and I also get cancelled. Finally we got pi by 2 is the answer. So here pi by 2 is the answer. Here the picture is nothing but we have to take the pole or not. So first one, modulus of z minus I is equal to 2. So modulus of z minus I is equal to 2. We have to expand this one. That is z equal to x plus iy. Z is equal to a plus x plus iy. So we have to substitute z is equal to x plus iy. Then taking modulus on both sides, finally we got what this, that is a x square plus y square, x square plus y square. Again, here this one plus 1 the whole square. So finally we got the circle for the equation. So fourth problem. Fourth problem is example for residue problem. Okay. So next fifth one. Fifth one, the integral. Closed integral f of z into dz. Evaluator around the unit circle on the complex plane for f of z equal to cos z divided by zs. First option 2 pi I, for second option 4 pi I, third option minus 2 pi I, fourth option 0. So here function f of z equal to cos z divided by z. So we have to find the pole, that is a simple pole. So for z equal to 0. So z is equal to, we have to find the residue for 0. Okay. For 0, we have the residue for z is equal to 0 is limit z tends to 0, z minus 0 into f of z. So here f of z is cos z divided by z. So z cancelled, we get cos z. So again substitute z is equal to 0. Finally we get 1. So for closed interval f of z into dz is 2 pi I into sum of the residue. So here residue is 1. So 2 pi I is the answer. So option A is correct. And then second, next one, x of z is equal to z divided by z minus a the whole square with the modulus of z greater than a. The residue of x of z into z to the power n minus 1 at z equal to a for n greater than or equal to 0 will be, first option a to the power n minus 1, second option a power n, third option n into a power n, third option n into a to the power n minus 1. So here x of z is equal to function given as z divided by z minus a the whole square with the modulus of z greater than a. So here also we have to find the residue for not simple pole. Here is of order 2. So residue of f of z at z equal to a is 1 divided by 1 factorial limit z tends to a d divided by dz of z minus a the whole square into f of z. So here f of z is z divided by z minus a the whole square. So again z minus a cancelled, we get final, we get z to the power n. So again substitute z is equal to a. Finally we get a to the power n into a to the z is equal to a. Finally we get a to the power n. Again differentiate those terms, we get n into a to the power n minus 1. So n into a to the power n minus 1, that is D option is correct. So seventh question. consider the circle modulus of z minus 5 minus 5y equal to 2 in the complex plane x comma y with z equal to x plus iy. The minimum distance from the origin to the circle is first option 5 root 2 minus 2, B option root 54, C option root 34, D option 5 root 2. So first take the circle, that is modulus of z minus 5 minus 5y equal to 2. So here 5 minus 5y, we have to take this one, and then z is a complex variable. So we have to substitute the complex variable z plus xy. So we have to combine the complex real number and then imaginary number. We get a circle of radius 2 and a center 5 comma 5. Then question is the minimum distance from the origin to the circle. The origin to the circle, the minimum distance is. So we have to find OP. OP. So OP is square root of from figure. We have to find from the figure. We get square root of 5 square plus 5 square is 25 plus 25 50. There is we have to simplify 50. Root of 50 is 2 into square root of 5. So again, OQ is minimum distance from the origin. OQ is minimum distance from the origin. So again, we have to find OQ. OQ. So here OQ is here. OQ is sorry. Here OQ is 2 into square root of 5 minus 2, as PQ is radius and is radius of 2. So again, eighth question. Let z cube equal to z bar, where z is a complex number not equal to 0. Then z is a solution of z square equal to 1, z cube equal to 1, z power 4 equal to 1, z power 9 is equal to 1. So we have to take the given equation, that is z cube equal to z bar. So z cube equal to z bar. So just multiply z on both sides. We get z power 4 is equal to modulus of z square. So again, by trial and error method, we got z power 4 is equal to 1 as the solution. That is, C option is correct. So again, ninth question, the value of the integral of the complex function, that is f of s is equal to 3s plus 4 divided by s plus 1 into s plus 2 along the path modulus of s is equal to 3s. A option 2 pi j, B option 4 pi j, C option 6 pi j, D option 8 pi j. So here given function f of s is equal to 3s plus 4 divided by s plus 1 into s plus 2. So we have to find the singularities. So that is pole that is we have to substitute the denominator as 0. This s plus 1 into s plus 2 equal to 0. We have to find singularity, that is minus 1 and minus 2. So again, which are inside the given circle, modulus of s is equal to 3. So again, we go for residue. So residue for minus 1 is limit z tends to minus 1, s plus 1 into f of s. So here f of s is 3s plus 4 divided by s plus 1 into s plus 2. Again, s plus 1 got cancelled. We get 3s plus 4 divided by s plus 2. So again, substitute is s is equal to 1. Final answer is 1. So second residue for s is equal to minus 2. S is equal limit z tends to minus 2, s plus 2 into f of s, that is 3s plus 4 divided by s plus 1 into s plus 2. Again, s plus 2 cancelled, we get 3s plus 4 divided by s plus 1. So again, substitute s is equal to minus 2. So finally we got 2. So closed interval, the question is the integral of the function. So finally we have to find the integral, that is 2 pi I into sum of the residue. So here first residue is 1 and then second residue is 2. So add those terms, that is 3. 3 into 2 pi j is 6 pi j. So next question, the value of the integral over c cos 2 pi z divided by 2z minus 1 into z minus 3 into dz, where c is a closed curve given by modulus of z equal to 1 is a option minus pi I, b option pi I divided by 5, c option 2 pi I divided by 5, d option pi I. So here f of z is so function. So we have singularity for this function. This denominator equal to 0. So z equal to 1 by 2 is only the singularity. So for z equal to 3, we have a circle. Is modulus of z equal to 1 is a circle. So uh, only singularity is z is equal to 2, not z equal to 3. So residue of f of z, f of residue of f comma 1 by 2 equal to limit z tends to 1 by 2 z minus 1 by 2 into f of z. So here we have to simplify those function. So finally we get 1 by 2 into cos of 2 pi z divided by z minus 3. So again substitute z equal to 1 by 2. So finally we get 1 by 5. So again, the integral for those function equal to 2 pi I into sum of the residue. So here sum of the residue, that is 1 by 5. So finally we get 2 pi I divided by 5. So C option is the correct answer. So 11th question, given x of z divided by z, x of z equal to z divided by z minus a the whole square with the modulus of z greater than a, the residue of x of z into z to the power n minus 1 at z equal to a for n greater than or equal to 0 will be a option a into a to the power n minus 1, b option a to the power n, c option n into a to the power n, d option n into a to the power n minus 1. So given function is z divided by z minus a the whole square. So we have to find residue for z is equal to a. So not the integral. So here we just find the residue for z is equal to a. So but the pole of order is 2. Here pole of order is 2. So we have to write the formula for pole of order is 1 divided by 1 factorial limit z tends to a d by dz into z minus a the whole square into f of z. So here f of z is z to the power n divided by z minus a to the power whole square. So we have to write this as z power n. So we have to differentiate z power n is equal to n into a to the power n minus 1. So for the function sin z divided by z cube of a complex variable z, the point of z equal to 0 is, for again a gate question. First option pole of order 3, pole of again second option a pole of order 2, third option pole of order 1, not a singularity. So here solution is function is that is sin z divided by z, and then point z equal to 0 we have to substitute. So answer is 1. Therefore the function has z equal to 0 is a pole of order 2. So option B is the correct one. Again 13th question, contour C in the adjoining figure is described by x square plus y square equal to 16. The value of integral over C z square plus 8 divided by 0.5 z minus 1.5 j into dz. Here j equal to root of minus 1, and here is z plane for those function. So option also given minus 2 pi j, 2 pi j second option, third option is 4 pi j, fourth option is minus 4 pi j. So function is z square plus 8 divided by 0.5 z minus 1.5 j. So we have to rewrite the given task, that is zero point 0.5 be write as 1 by 2, 1.5 be write as 3 by 2. So just rewrite the given equation, given function, that is 2 into z square plus 8 divided by z minus 3j. So here 3j is the singularity, that is a pole, is a pole, and again of order 1. So given circle is x square plus y square equal to 16. X square plus y square equal to 16. So in the singularity z equal to 3j is lie just inside those circle. So we have to find the residue for 3j. That is limit z tend to 3j z minus 3j into f of z. So z minus 3j get cancelled. Finally, you get 2 into z square plus 8. So again 3j, substitute 3j for z. So again finally answer is minus 2. So final last closed, we have to find the closed integral f of z into ds. So for closed integral f of z into ds, formula is 2 pi I into sum of the residues. So here sum of the residue for singularity z equal to 3j is minus 2. So multiply those this one, we get minus 4 pi j. So recording கொடுத்துட்டா இல்லைமா?